Now we move on to the molecular formula. So the empirical formula was a simplified version. So I give this simplest whole number ratio in which the atoms are present. The molecular formula is more useful to you. It gives you the actual number. So like if a molecular formula might be C2H6, tell me there's 2 carbons, 6 hydrogens. The empirical version of that would be CH3, just simplified down. So that's what actually the compound is. That's the simplified version. Right, in order to work out the molecular formula, you must know the empirical formula, and the relative molecular mass of the molecular formula itself must be known. So say for example here, the empirical formula for benzene is CH. Its relative molecular mass is 78. Find the molecular formula of benzene. So the empirical formula of benzene is CH. One of these will be CH units. The total mass of the compound is 78. If we work out the relative molecular mass of this empirical formula, we see there it's 1 by 12 carbon. 1 by 1 is 1, is 13. We want to see how many of these CH units are in 78. We want to see how many of these 13s are in 78. So 78 divided by 13 is 6. Therefore there's 6 of these. The molecular formula is C6H6. So what you do is find the molecular formula of the empirical formula, or relative molecular mass of the empirical bit, and then divide it into the total relative molecular mass. Pause it and go over that for yourself. The empirical formula of glucose, CH2O, its relative molecular mass. So you've got one of these CH2O units. The relative molecular mass of this CH2 unit is 1 by 12 is 12, 2 by 1 is 2, 1 by 16 is 16, 14 is 30. The relative molecular mass of the compound is 180, so 180 divided by 30 is 6. There's 6 of these CH2O units. So that means there's going to be 6 carbons, there's going to be 12 hydrogens, and there's going to be 6 oxygens. Next one. The empirical formula is C2H4O. Its relative molecular mass is 88. Find the molecular formula. Same again. Work out the relative molecular mass of this bit. 2 by 12, 24. 4 by 1 is 4. 1 by 16, 16. So we're 20, we're at 44. Now work out how many of these are in this here. So 88 divided by 44 is 2. There's 2 of these units. So your molecular formula is C4H8O2. As I say, stop and try the questions there in your notes. Got a few answers there done. Also look at the questions in your book, molecular formula, and read up in that section as well. Page 162, 163. Important to learn the definition like it is in the empirical formula. There are your 2 definitions in this. I'm going to batter on, but pause as I say. Work through those questions. But rather make it a new video, I'm going to tip away. Relative molecular mass of propane is 42. It contains 85.7% carbon and 14.3% hydrogen. Find the molecular formula. Now, as I said there 2 minutes ago, in order to work out the molecular formula, you need to know the empirical formula and the relative molecular mass. So we've got the relative molecular mass. We just need to get the empirical formula here. To get the empirical formula, we've got percentages. What we do is change that to grams, go back to moles. So the number of moles of carbon, 85.7 grams, divide that by 12, and your number of moles of hydrogen, 14.3 grams, divide that by 1. So we get 14.3 moles there, and 85.7 divide her by 12, and we get 7.14 moles. Now divide by the smallest, like we've done before. 7.14, 7.14, we get 1, we get 2. Therefore the empirical formula is CH2. Now, if we work out the mass of that empirical formula, we've got 1 by 12 is 12, 2 by 1 is 2, 14. We want to see how many of these 14s are in 42. 42 divided by 14 is 3. Therefore, the molecular formula is going to be 3 of those units, C3H6. Difficult enough. Next one. The relative molecular mass of ethanoic acid is 60 and contains 40% that's blah blah blah. Change your percentage into grams, go back to moles in each of them. So your number of moles of carbon, 40 grams divided by 12. Your number of moles of hydrogen, 6.66 grams divided that by 1. And then your number of moles of oxygen, 53.33 divided that by 16. So we have 3.33 for the first one moles, 6.66 here. There's this is 3.33 as well. Divide by the smallest. One, two, 1. So the empirical formula is CH2O. Now if we work out the mass of that empirical formula, we have 12 and 2 is 14, 30. Just I'm getting our tight for space. I want to see how many of these 30s are in 60. We get 2. Therefore your molecular formula, there's 2 of these units, double that, C2H4O2. Now if you're feeling confident, pause it. Try these questions yourselves, be no bother to you, or go back over them examples. There's your questions, pause it, try these. I'll just do the solutions to them now, but you pause it, try them, and then do the ones, as I say there, 10 to 15. Right, work out the number of moles. That's the first thing you did. Number of moles of carbon, 54.54 grams, divide that by 12. Your number of moles of hydrogen, 9.09 grams, divide that by 1. And your number of moles of oxygen, 36.36 grams, divide that by 16. 54.54 divide that by 12, what do we get? 4.55 moles. 9.09 moles. And 2.27. Divide by the smallest, which is 2.27. We get 1. 4. So you get 2 there, yeah. 2. So the empirical formula, tight for space, is C2H4O. Now, what's the mass of this empirical formula? 24 plus 16 is 40, 44. How many of them is in that? 88 divided by 44 is 2. Therefore, your molecular formula is double that. That's C4H8O2. And the last one there, work out the number of moles of carbon. Change your percentage into a gram, 26.7 grams, because then we can go back to moles. Number of moles of hydrogen, 2.2 grams, divide that by 1. And then your number of moles of oxygen, 71.1 grams, divide that by 16. So we get 2.2 moles. 71.1 divide that by 16. 4.44. And the top one there, get 2.2. Divide by the smallest, they're both the same. 1, 1, 2. So the empirical formula is CH02. Work out the mass of that, 12, 13, 2 16s, 32, 32 and 13 is 45. So 90 divided by 45 is 2. Therefore, our molecular formula, double that, C2H4, oh H2, sorry, C2H2O4. You try those questions now.